So I'd like to say welcome to the GAA's 5th webinar on synthetic diamonds. We're going to have the presentation for about 45 minutes. Then we're going to have a poll that you get to answer some questions about synthetic diamonds, and you're going to learn a lot tonight. And then we'll have our Q&A. I'd like to introduce Sarah Claire Edwards, who's one of the most recognised valuers in WA and recently valued the Perth Mint Pink Argyle collection, yes?
Yeah, the discovery coin, yes.
Fabulous. And John Chapman is also being very kind. John has been with Rio Tinto for over 30 years and recently retired from there to start his own business with synthetic diamond identification equipment and other equipment using optics is his specialty. So thankful for you guys coming in and doing all this work for presenting to us. I'm going to bow out now and leave it over to you. I'll come back after the video and do the poll.
Okay, well, the title I see has got synthetic diamonds and how to identify them, although that's sort of the main thrust of perhaps which initiated this. We'll also give a general discussion on the synthetics, a bit of the history, the production methods, and Sarah will put in her 2 bobs worth on pricing, valuation, grading, and that sort of thing. But just to kick things off, just from a historical perspective, oh, hang on, I thought we had this solved. We're trying to go on to the next slide, and voila.
I can do that.
That's why it's a team effort, because Sarah's good at IT. But, yeah, just putting synthetics into perspective, it was 70 years ago when the developments were starting on them, and they evolved over the subsequent decades, and it was really the HPHT ones which took a leading position in the market. And more recently, about 20 years ago, the CVD technique came along. I should point out at this stage, some of these terms will become clearer in the main presentation, which is in the video, but I'll assume a lot of you have got some knowledge already, or a lot of knowledge, in fact, on some of these terms. And really, it's in the last probably 10 years which they've made quite an impact on the market. And as an example, it was only last year where India was exporting about $500 million worth of lab-grown or synthetic diamonds. But at this point, so that gives you sort of just why it's an important part of our industry. And I'll pass over to Sarah now, who will talk a bit more about the grading and the like.
Hi everyone. So I thought this evening that I'll just run through and talk a little bit about the terms. So at the moment, CIBJO is in the process with a draft where they're going through and creating the harmonised set standards and principles for what they're going to be doing with the laboratory working group and the terms that they're going to recommend. In our meetings in 2019, there was discussions at CIBJO looking at terms that laboratories should be using and should be used within the industry to protect the consumer. And those terms that they're looking at using is laboratory grown diamonds and laboratory created diamonds. They're looking at having no abbreviations, so nothing like lab diamonds. They're not looking at not having terms like synthetic diamonds, not abbreviations like LCD or LGD, just making it more standard. So the documents are in draft, and I haven't actually seen what's going to come, but a lot of the laboratories you'll see have adopted this. Another thing for some people who aren't really in the diamond industry so much and who have come more over from gemmology, it's interesting when you're looking at a diamond where to describe a natural diamond, we don't actually use a prefix like we do when we're talking about, say, a natural corundum variety ruby or something like that. For a diamond, we just call it a diamond, which means it's natural, and any other prefix like laboratory grown diamond, that then would mean it's, you know, synthetic laboratory grown, even though it's grown in a factory. So over just to looking at certificates, I thought it's interesting to see what certificates are out in the market and what people are using. So HRD are using a yellow certificate, and they're using the term lab grown. So they haven't adopted that terminology yet of laboratory grown diamond. They call it laboratory grown on their certificate, but they laser inscribe the girdle of the diamond lab grown, and they put that number on the report as well, what they're lasering. They also follow the 4 C's when they're grading. There is recommendations that you put LG and then the colour or clarity grade. They're just using the colour and clarity grades that they use for natural diamonds. IGI, they're also using a yellow grading report. It's interesting here because on their certificate, they laser inscribe laboratory grown, whereas on their website, they write lab grown, but I believe they're using laboratory grown when they are certifying and laser inscribing a diamond. Again, they've got a yellow report and they're doing their same grading as they do for diamonds. GIA, they're doing it a bit differently. They're doing a blue certificate, and their certificate has in big writing at the top LGDR, and then they're also using the term laboratory grown and laser inscribing that on the girdle of the diamond. These reports are not hard copy reports like the natural diamonds. They're only a digital copy. And you've got 2 options with these. You can have plotted inclusions in their full report, or you can also get their dossier where you don't have the plotting on there. And again, they're using the same scale as what they use for their natural diamonds. Another thing that's happening that was discussed at CIBJO in 2019, November, is that customs codes. So the customs, they're looking at making us have to declare synthetic diamonds when we bring them into the country. They're looking at adopting this in January 2022. And so this is basically CIBJO and JAA had been in touch with the Australian government, and it's been approved, this classification system. The idea is obviously to protect the industry and monitor the import and export of the synthetic diamonds. So you'll be using a customs 8-digit HS code. So we've already got HS codes for when you're bringing in diamonds that are rough or to comply with the Kimberley process. So sometimes I'll work at Border Force looking and separating them to see if it's rough, if it's been sawed, if it's been bruted, and so forth. So you can see here there's a code HS7104.21. That's a synthetic diamond. It's been unworked or simply sawn or roughly shaped. Relating to a rough laboratory grown diamonds. Then there's another code, HS7104.91, synthetic diamond, otherwise worked, relating to polished or worked laboratory grown diamonds. This is something that I will be updating as when it's definitely coming through, as I'll be liaising with Border Force. I know that other countries are already using temporary codes and started to implement this. So already they are watching it in sections of Europe and also in India. So they'll be able to see the volume that's coming in and out. But I believe it's set for 2022 in January. And now pricing. So looking at pricing, this is one that you're going to see statistics that vary so much. And you'll see, say, like De Beers with their light box, that they've got really cheap pricing for their 1 carat stones. These stones, I guess, about a decade ago, you were looking at higher pricing and they were coming in maybe 20% less than what a natural diamond was costing. Whereas now it's more closer to kind of 60% cheaper than a natural diamond. So they're over half the price. They're less than over half the price less. So if you look at this first chart, I've got these actually from the Gem Guide, and they've been based from LGDEX. So they're kind of pricing and data that they've collected. You can see here that today, a 50-pointer FVS2 stone, the average for a laboratory grown diamond is 1,075. Whereas today you can see that a natural is more like 2,850. These are, of course, US prices. You can obviously read through the other ones there just to see that there is a difference, more than half the price cheaper. If we look here as well, this just shows that obviously they have been decreasing in price. And you can see here that a 50 pointer, again, a D to F color in a VS. The synthetic or laboratory grown diamond was sitting in 2019 in the fourth quarter. You're looking at $1,050 to $2,250, whereas now they've dropped a lot and it's, you know, $600 to $1,450. And that's it from me. Now I'm going to put you over to John, and he will run over some instruments.
This tends to be my area, and all these will be, not all of these, but the movie that will be shown shortly will have its main focus on the instruments and detection techniques. But I just want to point it out that there are many available instruments on the market based on different technologies and different prices. So you can get anything from sort of $500–600 up to tens of thousands, and they both all have their pros and cons depending on whether the stones are mounted or colored, or whether it can detect imitations, and sometimes their size limitations. So that just gives you, and there's probably more than that now. This I compiled last year. As for the general characteristics that distinguish the three types, again, this is just a bit of a preamble, and I'll be covering them in the movie. I probably should show these at the end, but I'm telling you them now, and then you can look out for them in the movie and consolidate the learnings there. But the HPHT ones and CVDs both have a characteristic of basically having no nitrogen if they're the colourless variety, which is the main ones, which are an issue on the market today. There's growth sectors, which is the way they're grown are quite different, and that can be revealed under particular lighting. It shows what they call growth sectors in there. The strain within the stone can be seen or birefringence, which can be revealed in cross polarizer filters, which some of you are familiar with, and that's quite distinctive between the three types of diamond. And then there are the inclusions within them, where the likes of HPHT will tend to have metallic ones. Now, unfortunately, I overlooked that in the movie you're about to see, so I mention it now because they are quite distinctive in HPHT diamonds. They'll tend to be linear or metallic looking, and whereas CVD tends to have sort of black spots, and natural diamonds will have, if any, sort of mineral inclusions in graphite. But the other differences are sort of optical ones, where HPHT will phosphoresce. There's some distinct fluorescence differences, which we'll get to in due course. And spectroscopically, you can see different impurities that the synthetics and the naturals offer. So I've just touched on these inclusions in the HPHT because they are overlooked in the movie. But in the summary of the everything that's shown, essentially there are two growth methods, CVD and HPHT. Your synthetic colorless diamonds are type 2, they have very little nitrogen, and you have a fluorescence characteristic that the natural ones have a long wave that's stronger than the short wave, and there's phosphorescence under the short wave will indicate synthetic. And because of those inclusions I showed earlier, you'll find that the HPHT can often be attracted to a strong magnet. As for the growth methods, the HPHT, for whatever reason, they tend to be very strain-free, and so no birefringence patterns are observed. That's regardless of color. I've already mentioned the inclusions, and also the columnar patterns under cross-polarizing filters for CVD. And for those who are able to go in a bit more detail, sophistication, which is what more labs are more inclined to do, is look at optical spectra, of which there's some distinguishing lines for CVD and, well, particularly CVD, but also natural, and not so much for HPHT. So that's a summary of it, and this is probably more used after the event, but you can ask for me later if necessary. But there's a bit of a flow chart of what techniques one can use in incorporating the fluorescence and metallic, magnetism and the like. So there is a bit of a system there, which Branco's refined to be a more elaborate looking chart there. But and when we come to the end of it, if you want to contact either myself or Sarah, there are the details, and there's some Instagram accounts there which you must follow, of course. But without much further ado, I say that's what's about to come. Some of that might make more sense later, but we'll now put you on to a movie which Sarah and I went to great pains to make, which hopefully you can understand, and we'll leave it over to you, and we'll get back to you in 20 minutes because that's the length of the movie.
Hello, how are you?
Thank you. What can I do for you today?
My name's Jill, and I just got these diamonds.
Oh, wait. I'm Jack, and you've got some goods you want to buy?
No, I just want you to look at all this stuff.
Oh,
There's so much of
Okay,
it.
see, you've got a lot of it. Don't bring it out here. Let's go to the back room, to the lab there, and have a look at it there. You might want one of these after your bicycle ride.
Oh, thank you.
On our way there. Follow me.
I love the messages in Barchi. You know, I got all of these diamonds actually for buy last week. How much are they worth?
Well, that depends on whether they're natural or synthetic diamonds.
Like, as in a CZ or something?
No, that's an imitation diamond. I'm referring to a non-natural diamond.
Oh yeah,
Non-naturally grown diamond.
I read something somewhere. Was it a CBD diamond?
CVD, ah yes. Let me tell you about those. What's one of the methods of growing diamonds? Let me show you. What you have there is, we have a chamber, usually made of glass. The air in the chamber is evacuated and a mixture of methane and hydrogen is introduced. The carbon in the methane becomes the building blocks of a diamond through an ionization process initiated by microwaves. The carbon deposits onto a diamond substrate and slowly builds a diamond plate, layer on layer.
So what's the hydrogen for?
The hydrogen is critical to etch away any graphite that has formed, because the pressure is near or less than atmospheric pressure where diamond is unstable. For growth in a diamond-friendly environment, high pressure and high temperature conditions are employed, the HPHT, which we referred to earlier. The heart of an HPHT system is a cell in the middle where the actual diamond grows. For that there's a seed and a molten solution of iron or nickel or cobalt into which carbon is dissolved. Often this diamond source is actually diamond powder of a lower industrial nature anyway. That dissolves and migrates down and precipitates on the diamond seed and ends up growing the larger diamond. And this all has to be done under pressure and under high temperature. There are various ways of producing the pressure. In this instance, with two rams in opposite directions around a fixed, what's called a belt here, but there are other methods such as with a split sphere and even a donut arrangement. The split sphere one is a popular one because it's a much smaller press and therefore cheaper as well.
Okay, I see. Well, really, that's great and pretty technical, but how are you actually going to identify these synthetics or whatever you call them? What toys do you have over here?
Let me show you what we have. And they're not toys, they're instruments, by the way, Jill. Well, here they are. They're multiplied from the small to the large. We have a magnet, a cross-polarized filter, also known as a fluoroscope, a system for looking at the fluorescence and phosphorescence of a stone, and our latest piece of equipment, a spectrometer for looking at the absorption and the photoluminescent spectra of a stone. And one of the oldest pieces of equipment, or still of use to gemmologists, a loupe and a microscope for looking at the inclusions in a diamond.
So what's this thing for?
Ah, yes, that's a prototype. It's also known as a doublet buster, but we don't need that.
All right, well, let's just get it going, hey?
Well, what have you got there? Show me what you've got. Oh, gosh.
I've got lots. I got these from a guy last weekend. He
Well, there's
said,
quite a bit here. What we'll do is, I see you've got coloured diamonds as well. We'll leave those to later because...
oh, so they're
time's
definitely
of essence.
diamonds?
I'll assume that they are, but I'll look at the colourless ones first and see. Here.
Oh, sorry. He just gave it to me on the weekend and I've been wearing it ever since. He said I could sell everything. I'm just really after some cash. So what tests are you going to start with?
We'll start with the fluorescence. That's the easiest test to use, for which we have two wavelengths, a long wavelength and a short wavelength, also called LW and SW. Okay, we place the diamonds into a viewing area here. I think we'll
So, do they always fluoresce blue?
Most of the naturals will fluoresce blue, but they can come in a range of colours depending on the inclusions in them, the defects, and also the colour of the diamond. As this chart shows, and also it depends whether they're synthetic, whether they're treated, or whether they're imitation, the CZ you referred to earlier. I'll use my phone so you can see what's happening inside under this, but normally you can look through the eyepiece, and there's an app here which helps in viewing what we're looking at. So there's a long wavelength, and you can see there's the diamonds.
Oh, they're glowing. They're all different strengths, aren't they?
And they're a bit dusty as well. But the key here is to compare the long wave and the short wave reaction. So I can photograph the long wave and then switch over to the short wave.
Oh, they've changed. Those ones almost have a bit of yellow.
Well done indeed, and that's the sort of thing we're looking for. So I can take a picture of the short wave, and
so
then
those ones got fainter and those ones got stronger. Is that right?
you're quite right, and we can confirm that with this little comparison thing here, which I can take it off now, and you can see that some of them indeed are brighter in the long wave and dimmer in the short wave, and they're the natural ones. So this one here certainly is a natural stone, and this one and looks like that one, whereas these other ones here are suspect synthetic diamonds, these three at the top here.
Will I still get lots of money for those ones?
Well, you won't get as much, but I want to show you something else as well, which helps us confirm the nature of the synthetic diamond. If I go back to what we were looking at, you might, let's go back one further. This is the short wavelength fluorescence, and you'll notice when I switch it off, two of them.
Oh my gosh, you can see it glowing.
That's what is known as phosphorescence.
And you didn't even need to turn the lights off in here.
Well, that's the beauty of this system, that the older ones, they needed that. Now, those ones that phosphoresce are HPHT, because by virtue of some of the inclusions that are in there. Okay, now we'll look at the melee.
What's melee? Is that another type of synthetic diamond?
No, this relates to the size of the diamond, so small ones, usually a couple of millimeters in diameter. But the thing about the melees, if they're synthetic, they'll only be HPHT on the whole. Well, 99% of them will be HPHT because it's uneconomic to make them by CVD methods. So since we're only looking for whether HPHT or not, it's phosphorescence, which is the
Afterglow.
technique, the afterglow indeed. So I've got a bit of a tray here to help identify if any of them do glow, and you might recall we put it under the housing So I've actually got a melee version of that particular software, and you can't really see the stones there, but when I switch the UV off,
Oh, whoa. But that one's not glowing, is it?
they all seem to be glowing. If we go back to what we had before, and you can see all of them there. I could record the pictures and compare them, but it's...
oh yeah, it is glowing.
We can do the same comparison as before. And generally speaking, if someone's going to have synthetic diamonds in a parcel, there'll be unlikely to be 1 or 2 stones, but either a large proportion. In this instance, they were all HPHT grown. With the melee, because it's HPHT, the ion inclusions also mean that it might be magnetic. And we can test that with having a rare earth magnet, and if they are, oh look, there we have an example of one of the ones that have been picked up. There's another one as well. So that's not a definitive test, but it helps confirm that they are synthetic.
Can a natural diamond have iron in it?
It can, but they're very rare to find one that's magnetic.
So Jack, can you use the magnet on the bigger stones?
It certainly can. Let's try it on those ones we looked at earlier. You might recall, I think the ones at the top were, oh look, yes, certainly, that one lifts it. And let's see if you can see if there are any more.
Yes, I got one.
There's another method too, and that is to use cross-polarized filters which look at the birefringence within a diamond. So natural diamonds and CVD and HPHT both reveal distinctive patterns. Between cross-polarized filters, you can see a birefringent pattern representing the internal strain of the diamond. For CVD, it is a nice columnar pattern, whereas for HPHT, there's no pattern at all. While for natural diamonds, that's what is called an anomalous birefringent pattern. These techniques are fine if one's dealing with loose stones, but when it comes to jewellery with mounted stones, the options are a bit more limited. Returning to our fluorescence instrument, I'll just look at this piece of jewellery of yours, nice pendant.
Yeah, I don't know if I'll sell that or if I'll keep it, you know, because although my name's Jill, my surname starts with an S.
Yes, well that is a problem.
Okay.
Okay, we'll have a look at these. That's the long wave, over to the short wave. Always do the long wave first in case something's phosphorescing. And if we compare these, you'll notice that really most of them are all fluorescing brighter in the long wave, except the one that's questionable is up here. It's actually marginally brighter in the short wave. It's also a slightly yellowy, greeny colour, but we can look at that with another technique in a moment. We can also use this to look at rings. This interesting one of yours with green diamonds on the edge. This ring has a blue long wave fluorescence, which seems marginally brighter, or noticeably brighter than the short wave fluorescence. However, it's slightly concerning insofar as the long wave one is not your traditional blue you expect from a natural diamond. But we do have another technique for checking such stones, and that is to use spectroscopy. First we'll look at a loose diamond, one of the ones we looked at earlier.
Okay. So you're putting the CVD diamond in this toy, what's this called?
The spectrometer. Yes, I don't know if it's a CVD diamond, it's a diamond, one of those ones. It's one of the ones which came up as being suspect, and if we look at it under PL, which is to shine it with a laser, in this case 405 nanometers, it'll glow. I can probably show you quickly. Ooh. No, probably can't because it's not very bright at all.
Don't worry, I have my sunglass lenses.
That's always good to be ready for safety matters. And you'll see this has produced a very strong peak at 738 nanometers. That's indicative of silicon and vacancies in the crystal. You might remember the description I gave on how CVD is grown. It's in a glass chamber usually, and that has silicon in it, and so some of that contaminates the CVD. But you can get it in nature, so that's not definitive. But you can see two very small peaks here, which if I change the scale, there are two more peaks here. There's one at 678 and one at 542 nanometers, and they are from a nitrogen vacancy center, which is associated with CVD. So the combination of those three peaks means they are CVD.
So I was right saying it was CVD. My guess was it was CVD because it wasn't magnetic and it didn't have, what's that thing called? That when
Phosphorescence?
Yeah.
Yes.
So you've got this peak, this peak, this peak, and then you've got this one.
Ah, well, you might remember when you came and you said, are they all diamonds? Well, that's what's called a Raman peak, and it's specific to diamond and the wavelengths of radiation. So it's at 430 nanometers on that, which is diagnostic of diamonds. So all diamonds should show a peak with this system at that wavelength. Okay, we can look at this ring in the same initial PL mode. Cover it up so you don't get zapped by the laser and turn it on. Now that silicon vacancy peak at 737 isn't always there, and here's a CVD on the ring, and it shows those two peaks relating to the NV center.
And there's the 430 again.
Yes, that'll make you happy. So that is also a diamond as well. So you haven't been duped there. They all seem to be diamonds. We can also look at a diamond under absorption, and using that same one, which was CVD, you can look at the absorption spectrum, and that peak is also a strong absorption at 737 nanometers.
So what's absorption? Are you putting a different light through, or what are you doing there?
This puts white light across the spectral range of almost in the ultraviolet into the near infrared, because 737 is beyond the human vision, so it's handy to have another method like this, because the alternative is a spectroscope which you look through and see a spectrum, and you can see lines there, but it's a bit hard to see ones beyond the range of human visibility.
So what's a natural diamond look like?
Well, in absorption, I grabbed one of those ones we had there. You get a distinctive line over here. That's right, you can see a peak there.
Oh, so that's the line you were talking about before, 430.
No, that's the Raman one. This is in absorption mode, and it's at 415, which is due to 3 nitrogen atoms, which you'll only get as a cluster in a natural diamond. And we can also see it, should be able to see it in PL mode. And that's where you should see the peak you're referring to, but it might be drowned. So I can switch over to that, turn it over to PL mode, and we'll see what we've got. And there's that peak, same peak, but now it's an emission one at 415 nanometers. And the one I mentioned, that's the peak which tells you it's a diamond, although it is superimposed on perhaps another peak that's there.
Then what's this one?
Oh, that's all related to that 415. So that's, in fact, the blue you see when the diamond's fluorescing. Another spectroscopic technique uses infrared light. Such spectra shows you details of the nitrogen. There's a region in the spectrum which shows the nitrogen here, along with the standard diamond one and a little hydrogen peak as well. This is a normal diamond, but then if we look at some other ones, for example, this one has a lower amount of nitrogen there, which is in a couple of states, A and B. I won't bore you with those details. But a third type has no nitrogen at all. You can see in this area where the nitrogen is supposed to be, there's no nitrogen. These are type 2 diamonds.
So Jack, don't you have like a piece of equipment where you can just press a button and it tells you whether or not it's a natural or a synthetic?
Yes, there are numerous systems on the market that are based on either fluorescence and phosphorescence or spectra. The devices are automated versions of basically what I've shown you. Though another popular technique for low-cost devices is to detect UV transparency.
how does it actually work?
Well, you see, colour synthetic diamonds are type 2. That means they have no nitrogen in them, just like I showed you with the infrared spectra earlier. And such diamonds, they transmit ultraviolet light. And also 2%, about 2% of natural diamonds are type 2. So these ultraviolet-based instruments are very good as a screening device, but they're not foolproof on account of those other stones that will also show up as being synthetic, but actually they're not. So you need to do more testing than just rely on screening devices.
And what about, you said you're going to do some testing on my pinks or those other coloured stones that I collected before?
Yes, you can't use any of these instruments for colour stones on the whole. They're only for colourless. So for those colour stones, they're special cases, and we'll have to look at that as a separate exercise, because we'll also be looking at treatments as well as just how they're grown.
Cool.
Could be natural and treated.
Yeah. I've really got to get going,
okay.
But I might want to learn more about it. It's quite interesting, but you know, pretty overwhelming.
Well, ride safely.
Thanks.
See you later.
So our question and answers. When a jeweler's torch, I don't know if you had a chance to check that question. When a jeweler's torch heats up a diamond, if they're doing a retip, a synthetic diamond, there's been anecdotal reports that the synthetic diamond changes colour.
Yes. I was going to work through the list, but it doesn't matter. You give me that question. CVD will change color under heat and under UV. With UV, it's in danger of becoming darker or lighter, one or the other, and the heat does the opposite. Strange enough, actually under UV, it goes a darker color, and under a torch, it'll go a lighter color, but that's only a temporary color change, and in normal daylight or in an office environment, after about half an hour, it'll return to what it was. So I would say that's the evidence. There was an article that De Beers wrote in Gemmology a few years ago, and they looked at that phenomena. And I suspect that's where the evidence, and I've noticed it as well, just under the jewelry inspector for CVD coated CZ, that tends to go.
Yeah, we
brown.
had those ones that went brown that I
Yeah.
wrote that, that report on. We've got images of it.
Which also means it could lend itself as a test.
Yeah.
A CVD test, does it change color? But it doesn't always happen. It can be quite subtle.
When we first got diamond coated CZs, I brought them over here and had lunch with John, and we put them under shortwave and we left them outside for the duration while we had a nice lunch, and we came back and they're
okay.
I don't know if they've got back yet, but they still hadn't got back after the lunch.
Oh, okay. Well, that might be a CZ specialty.
Excellent. John Burke is asking approximately what percentage of diamonds have shortwave fluorescence?
Yeah, it's a good question. So when it comes to whether a diamond's got fluorescence or not, a lot of it's got to do with how sensitive your equipment is. Like, so if we're talking about long wave, even though a lot of diamonds will be described as having none, if you crank up the sensitivity, you can always detect usually something. But generally speaking, in the absence of any high-tech, super sensitive equipment, probably in shortwave, I would say probably 30% would have a noticeable fluorescence, but of course it will be stronger when you go to the long wave, but it's usually visible there to some extent.
Can I just add something in there?
Oh,
just with your PL inspector, your jewelry inspector, actually, because what I notice when I'm valuing is that a lot of GIA and other ultraviolet lights, but specifically yours, because it must be that little bit stronger, that when you get a diamond report that says no fluorescence, I'm normally seeing faint. When I see faint, I'm normally seeing medium. So I've got to just be aware of what equipment, and I've got all different light box, like UV boxes that I can cross-check, and now I know. But normally you're seeing a bit, even if it says none on the reports.
Thanks. Helen is asking, is the price cheaper now as there are more laboratories and more diamonds available?
Okay.
I think that it's one of those things. If you look at De Beers, who have come in with Lightbox charging US $800 for a carat, they're doing CVD diamonds and they're from VS clarity up, and they're doing a range. They're not telling you what color you're getting. You're getting somewhere between a D and a J color. So they've been able to do this obviously with volume and also mixing that color range you're getting, and the cut grade on it's good. And I think that obviously they've come in and kind of driven that market to kind of pull, obviously the technology's evolved, so the costs have got down, but also I think De Beers would be driving something with their Lightbox a bit. What do you think?
Yeah. Well, definitely, but there's each year there are more and more producers, and the existing producers, a lot of them are expanding their capacity. So given that there's more on the market, then the price pressures will inevitably drive the price down.
And I believe the Chinese government bought into a lot of the equipment in China. So they were looking at more that some of the costs had got really driven down, because obviously that laboratory is not having that to pay for all that equipment. There's different beliefs if it's going to continue to drop, or whether or not they're going to have to stay like for melee at a certain price because of that cutting, because of the cost to keep cutting. So there's,
yes, that's the bottom.
Yeah,
the bottom cost will be the cutting.
Bottom cost of the cutting. Yeah.
Yeah, they can't reduce that cost.
Yeah. Yeah.
Absolutely.
And while we're talking about this, you asked before about, you know, are CVDs or HPHTs more expensive? And when I first went out and CVDs came out in the market, they were actually costing more than a HPHT. And I don't know specifically, I haven't gone through and done research looking at the two markets of the types of stones. But if we do look at that, you know, De Beers Lightbox are doing the CVD diamonds that have a range of colour, whereas you could probably sell a HPHT of a higher colour stone, and there's probably not that such a comparison. So that's maybe why the price is easier to be sustained. Yeah. And also you could get maybe an excellent cut. I believe that AGS, they haven't been valuing for, haven't been certifying laboratory grown diamonds, but they're doing it like a pilot run, and they're going to be giving ideal and excellent cuts on synthetics. So who knows how that's going to affect things.
Do we know if they're cutting all these synthetics to a really good cut? Are they still like some of the natural diamonds, cutting them for weight rather than?
I don't believe it's in the same way for weight. I did read somewhere, but don't quote me because I don't know exactly where it was. But it's not just the rough, because it's actually the volume in the laboratory, like the factories that are doing it. So I guess that they're getting a mixed standard coming out. But, and also when you don't have, De Beers are specifying that they're doing a very good cut. When other people, some stones are being mimicked for GIA certificates. So there's, you know, cutting exactly for a GIA cert, and they're being sold together with that document. So you're getting a copy brought to you, and it's got those measurements. So because in Australia, we've got a lot of excellent cut stones, then for the bigger stones, there might be the drive to cut them. But for smaller stones, I think it's a bit mixed.
I think Karina Tucci told me last week that that they're actually cutting some of the synthetics into the old antique cuts.
Well,
scary.
There's no reason why you'd cut a natural different to a synthetic in many respects. It's the same people are doing it. It's the same factories in India who are doing both. So it's not a specialist area really. But in this discussion, the last few minutes, I just want to point out, we've used the word laboratory, and this is why I don't like the word laboratory grown, because in our industry, laboratory is also a gem lab. So when we talk about a laboratory, it can be confusing.
We prefer factory, hey?
Well, I think they're factories. You go to these places, and they're not a lab; they're like a factory.
They've got backup generators. You were there with me in Israel, weren't we? We were there looking at all that equipment.
Anyway,
and couldn't take any photos. I think Helen.
We did. Did you see the cross polar filters up there? Those pictures, they were from that lab. Yeah.
Not of the equipment though. Helen, I think meant to say factories, or she was referring to factories when she said laboratories. Are there any CVD diamonds that can be magnetic? Isabel is asking.
The answer is a clear no. There's no way you can get iron or cobalt or nickel into a CVD.
And we're just asking more about the notes being downloaded, and we're going to organise something about that. And yes, it's being recorded, and you just need to email publicity@gem.org.au to ask for a link to the webinar recording. Ralph is asking, how does the hardness compare? I'm assuming between synthetic diamonds and natural diamonds.
Yeah. You hear odd reports sometimes, but usually it's a synthetic producer trying to push this product and say they're harder than natural, but really, essentially, they're the same structure, and there's no reason why one should be harder than the other. So I would say no, that there are no difference, and they are indistinguishable from a hardness point of view.
Has anybody tried to add inclusions to mimic natural ones?
Yes, I know that. I think that's being muted. It'd be hard to do. You certainly probably couldn't do it with CVD and even with HPHG. Could you add them? Not really. But that would be one way which producers would be in trying to develop if they could, because that'd be one way of cheating the system, because looking at inclusions is often a very good way of doing it.
Liz Stevens asked, why is there a huge variation in the retail market price from 3,000 versus 10,000 for the same 1.46 F VS stone?
Well, it would come down to the market. So different stores have different overheads, different staff. What do you think?
Is that
Katie White?
Is that comparison of synthetic diamonds, or is this a general comment on is the 3K a HPHG and the 10K a natural?
No, I've got to assume that she's asking that price, Liz, for synthetics. Why does synthetics sold between 3,000 and 10,000 for the same type of stone in the market?
Well, there's a variance in price depending on where I'm more familiar with the overseas market, but in saying that, I've been overseas for a little while, compared to the local market. And it depends what branding that wholesaler would be selling with their diamond, and what they might have a recommended retail markup, or the store might have their own markup. So I think that
I'm just wondering where Liz got that information. Was that from one of your PDFs that went up?
No.
Okay, so it's
I didn't put any retail pricing up.
It is. Sorry?
I didn't put any retail pricing up.
No. So maybe this is just the same for natural diamonds. You can go into a store and get it for 3,000, and somebody else, Tiffany or Cartier, will charge you 10,000 for the same thing.
Branding, marketing, depends if you're paying for carpet and curtains in a good street, or,
Well, I think even with synthetics, some retailers they do it now, I'm not sure, but certainly a few years ago, they would talk up the synthetic, say it's better than the natural, and charge the same price as a natural. I've had colleagues being offered synthetics several years ago at the same price as a natural. So
I do believe the markup can be very rewarding when it comes to laboratory grown diamonds. That's what I've heard. Very generous markups.
Gabrielle, CVD stands for chemical vapor disposition. Serena is asking, what's the app called in the video for the fluorescence? Well, it's the, I'll let you answer that, John.
Okay. It's called Geometrics, and it's free.
And it's good because it creates a file on your phone just for those stones. So when I am creating PowerPoints and looking back over, I have a whole library of fluorescence images. So it's really handy and easy to work with.
It is very handy for lots of different things. And it's just an app on the phone, and you download it from the App Store, whether you've got an iPhone or an Android.
It's better on
it is.
The Android works.
See, it's got a little diamond mark on it.
Disappeared.
And it's free. back to the question. Sarah needs to go to Hollywood.
Thank you.
We'd like to keep her here. We need
I went
her.
to Hollywood High School.
Seriously?
Yes.
Can one use, I never know whether to believe you or not sometimes.
I did.
Can one use unseparated UV light to check phosphorescence of HT diamonds with a small, cheap torch, not long wave versus short wave? That's from Frank.
Right.
So,
okay.
No,
the small cheap torches, they're all LW, and it's very rare to get LW to induce any phosphorescence.
But you can.
On that note, I've noticed some things that Grant Pearson, some instruments he's bought from China, and they say things like this is such and such wavelength, and he's tested them and they're not. A lot of these UV things that are supposed to kill the virus, and they're supposed to be, I can't remember the number, say 6, 7, 8 nanometers or whatever, but they're nowhere near it, and they're not going to do the product. So they're not going to do what this product says it will. So I found different things coming out of China. You have to really double check that they are what they say they are. That's mine.
One more thing, Frank, if you do have a torch and you want to even check that long wave, how it's working, you can bring it into class next week and we can just have a look at, compare different light boxes. But you won't from long wave get your phosphorescence.
But there is I have come across some HPHT ones. I don't know what it is about them, but they actually phosphorus just from white light as well. That I've put them in the dark. And
do you have any?
I've got one. I bought one for that purpose. It's an orange. It's just a weak orange glow, but it's there and it lasts for ages.
Frank, we'll have show and tell next week in class.
I'll bring it in.
Okay, I'm going to move this along because we're going over time. So there are a few very misleading ads going on at the moment with synthetic market. For example, Novita Diamond says gemmologists can't tell the difference. Does anybody have a problem? Does anyone else have a problem with that statement?
Well, we're not anybody, but that's probably a
well,
general
maybe
one
some
to the
gemmologists can't. Maybe they need to come and do some diamond grading.
Yeah.
But yeah,
buy a
it
jewelry
isn't a great slogan out there, because obviously we are trying to promote having people who are educated in the field, and we want people to come in asking for a gemmologist when they come into a store.
Well put. If a magnetic picks up a diamond, can we conclude it's HPHT given CVD and naturals do not have metal conclusions?
I think it's fair enough.
Gerard.
I think it's fair enough to conclude that, but I just say it with caution because I have read that look, some naturals might have a bit of iron in them or something. So I personally never come across them, but I think you can be 99.9% confident that it is. But I can see.
What about a
Sarah's
type 2B blue diamond?
Boron's not magnetic.
Okay, great.
So
there was something I swore we had one natural. I don't know which stone. We had one natural in the lab that was magnetic. And right. I don't know what color it was. Maybe it was blue. I don't know. Back in the day.
Exception to the rule.
But
and Newman,
if I can say, if when you're polishing and it's got cracks in it, you could get iron from the polishing wheel get in there. That might be anybody to be afraid. We couldn't be able to pick it up, I don't think.
Anne Newman's asking if she can have the correct answers to the poll. And if you just email publicity@gem.org.au, I'll email you the printout and the answers. I can't do it from this Zoom. Okay, Gerard is asking, I just asked that, didn't I? Helen, do all colourless HP, HT and CVD diamonds have phosphorescence?
No. Well, certainly CVD ones, most of them don't. And of the HPHT, I'd say probably 90% do, but I have seen some from a particular manufacturer where they had zero fluorescence and phosphorescence.
I heard they were working on how to knock it out.
Right.
Yes. So at this stage, you just have to still be careful, Helen. It's an indication.
Gina, the instrument's going to be on the GAA website shop, and I'm not quite sure of the price. I think it's around 600 plus GST. I'm not quite sure, but you have to check the shop shortly.
Hang on, but
And
Gina's asking about the Inspectrum, which won't be available from the shop.
oh, well, I beg your pardon. So I thought she just misnamed it. The Inspect was the spectroscope, wasn't it?
Yeah, that's right. So better speak to me directly on that one. It's a bit more expensive than, quite a bit more expensive than the jewelry inspector, and I don't think they'll be having it in the shop. But
do we roughly know how much? Because there's more questions on that.
Is there? Oh, I see. What price?
Don't do it.
yes.
Just going to email you.
Under
Chris?
5,000.
Under 5K.
Email John, Chris. I think that'd be a good idea.
Chris will be-
I'm not quite sure what Glenn's saying. What will it do to natural prices? Okay, synthetics. How's your crystal ball on what it's going to affect? I think there's a lot of things that are going to affect natural prices, like a pandemic. So it's hard to know. Glenn, do you guys have any opinion on that?
Well, I would say you could look at, for example, the emerald or other markets, gem markets, and ask, well, what effect did the synthetics have on that? And I think probably it didn't in those instances.
That's what we looked at, is that if you look at, like, say, a royal blue Burmese sapphire, or a royal blue, a Burmese saph, those are holding price. Whereas if you look at the bottom market, where there was more other like vanilla synthetics in, maybe that affected that for a little while. So I would say that I don't think like the coloured market or the top end would be affected as much as the more mid and lower end. But what do you think, Catherine? Valuer?
I'm trying to read the questions.
Okay, great.
I think you've answered it very well.
Okay, great. Well, I think that none of us really know, and I think that it's an interesting thing with these synthetics that have been coming down, and obviously, if people, they were at one of the talks I went to overseas with Amazon, the head of Amazon Jewelry. She was talking about the millennials are moving to looking at buying coloured gemstones, and they want a luxury story with it. And so they're liking the fact that some people are promoting this as ethical and things like that. So what they were suggesting at the ICA Congress was for the synthetic market, they didn't see it, or no, at Sibjo or one of them, and they were talking about how it is another market. It's not going to knock out that, it's another market. They're moving to something else anyway. So is it the generation that are going to change what they're doing?
Okay, we've got lots more questions, so I'm going to move them right along. The rare earth magnet, what is the cost of one of them, John?
Oh, about $2.
Daryl's, I think you can get them pretty much anywhere, can't you?
Yes.
John?
Actually, no, it's surprising. Where do you go? I'm not sure. I get mine if I have another product that needed them. So but I've got a few here, for example. So maybe
good, I lost mine.
If somebody's
in need.
I'm happy.
Ralph, you'll have to ask the NCJV if they've got different.
I'll throw them in with the jewelry inspector. How's that?
Oh, really?
Okay. The email address for the recording is publicity@gem.org.au. Ralph, you'll have to ask for the synthetic diamond prices from the NCJV. Publicity@gem.org.au. Monique?
There's a question there from Mark Seddon I can answer. He wants to know what the material is called. Pyrophyllite as a seal in the press.
Tell the question, because not everyone can see the question.
It says, John, on the HHT diagram, what material is used for the seal between the belt and the top and bottom press of the crucible? Yes, there's a bit of an interesting story about that, because the pyrophyllite is actually a natural material. I think it must be a bit like an asbestos, so that it can withstand the heat and it's sort of compressible. It's like a gasket, you might say. And they only find that in a few places. And one of them was a farm in Africa when Cecil Rhodes, I think it was him, and one of those early diamond pioneers, he said, right, I've had enough of diamonds, I want to get out of this. I'm going to go farming. So he bought this farm, and it turned out that was where pyrophyllite was. There was a deposit of pyrophyllite on it, so he couldn't totally get away from diamonds.
Okay. Do they have the same scintillation, Jill Penn is asking, as real diamonds?
Depends how it's cut.
But yeah, I mean, they're indistinguishable from a properties point of view. So if they're cut the same, they'll have the same scintillation. Yes. Although I'll just put in there that with CVD diamonds, sometimes you can see a sort of like a graining with them. I don't think that affects scintillation, but it is, I suppose, something which can be visible. And I've heard of, and I can believe it because I've seen a photograph. There's some people who can just look at a diamond and say it's CVD because of when you know what to look for.
Are there any Australians making synthetic diamonds?
No.
Not that we know of.
If anybody wants to, I can put them in touch with suppliers of the equipment.
I'm just, why the cobalt in HT diamonds from Frank?
No, the answer for that is, well, both, strange enough, cobalt, iron, and nickel are solvents for carbon, and yeah, so you can dissolve the carbon in it. And yes, interesting. Those three elements are also the ones that are magnetic or attracted by a magnet. I saw a question there from Jan. She's asking, can the spectrum be used for gems other than diamond? They certainly can. It can be used for, I haven't had much experience with it, but certainly your sapphires and rubies and even jade, it can be used for. Yeah, any gem that can either has a characteristic fluorescence or absorption lines somewhere in that region of 400 to 760 nanometers.
Is that right?
Yes. Someone else has asked that question too.
Where else? I finally found it. Thanks, Sarah, trying to make my life easier. This one for you.
Okay, well, that's a statement, so it's not a question.
Mm-hmm. Brilliant cut. I don't know what Jill Penn's asking with the brilliant cut, but a lot of the stones a lot of them are being cut for brilliant cut, but as Katie said before, some are being cut as an old cut, and they're doing all sorts of cutting. If the shortwave light.
That's what I mean. So if for UV, a shortwave UV light, what kind of eye protection should be needed to use it? Well, it depends what instrument you're using, but if you're using a jewelry inspector, then there's actually a filter before the eyepiece that will block out the UV.
So you could just go for a flip pair of sunglasses like mine, really, Gina. I've done that. A strong magnet.
Don't know what the question is there. Mm-hmm. Yep. Well, we come to the end of it then.
Is that the end?
I think so. We might have missed some. We're just trying to go back up, and I'm texting in some things. I think most of them.
Yeah,
I think we've covered them. And sorry to anyone we haven't. If we've missed your question, if you could just let us know right now, and we'll have another minute and answer your question.
Isabella Johnson has asked, are synthetic diamonds still being marketed as being better as they are conflict free? Well, that's
yes, they are being marketed as being,
I read an article, and it was saying that some have dropped that advertising, and they're just because it is controversial, and some are still finding that their sales, they just come in and show them two stones and there's less advertising with it, and they just pick natural or synthetic based on kind of prices and things. But I believe there still is some advertising.
And not only, well, someone that also decides conflict free, they'll also be arguing that it's more environmentally friendly.
With backup generators.
Well, just...
And lots of equipment.
They don't have to dig up the earth.
Yeah.
But
So
they do need a very big constant source, and they need a lot of electricity. So it depends on where they get their electricity from,
Yeah.
and they need a very good supply so it doesn't interrupt the microwave process, my understanding too.
Yeah, yeah.
Gina is also asking, if I have a short UV light, what kind of eye protection should I get in order to use it?
I've answered that.
We've answered
You
that.
probably weren't paying attention, Kate.
And did you answer the one about the gem pen?
No.
What would you test the general? Okay,
What do you test with the gem pen? What kind of technology they use for it?
Okay, yes. The gem. No, well, he sells it. The gem pen is great big fat pen, but that uses ultraviolet of different wavelengths, sort of quite short as well. So it goes shorter than the short wave that, for example, the jewelry inspector uses. So I think they have about 3 or 4 wavelengths, which makes the test not straightforward. You have to sort of put filters in and select the right one. But it works. It's good. It's
a question for you as well, John, from Julie. Can the app be used with any shortwave, longwave light box?
In principle, it can be used with any 2 photographs you want to compare. You can take a photograph of your kitchen before and after. It doesn't really matter.
Karina's asking about the opinion of your footprint of synthetics. Well, again, what we were saying before, the footprint of synthetics, it really depends on whether they're using solar or wind or gas or coal for their electrical source, yes?
Depends how they're asking the question. They're talking about the footprint in terms of a carbon footprint, or they're talking about the footprint is in the fingerprint, which is...
No, I think the footprint or could be the real estate.
Oh.
How big is the factory? Is that what she's referring to?
How much energy it consumes?
Oh, okay. Well, that's right. Well, quite a lot is the answer to that. Oddly enough, though, with CVD, their biggest cost factor isn't the power; it's the gas, because they're pumping a lot in and sucking it out. So they consume a lot of gas, and it has to be high, it has to be very pure.
Stuart Cole's written here that both conflict and environmental claims have been dropped. Seems Sibjo Natural, Diamond Council and lab groups seem to have come to an arrangement. Well, there are independents who are still advertising with these slogans. This is something that Sibjo has created in 2018, a laboratory diamond grading working group that is another committee that works with the Diamond Committee. And as I said, they're working on documents. They're in a draft state at the moment. So hopefully we'll have some guidelines coming out really soon.
We'll wrap it up there. Thank you guys so much. That is so appreciated. All the hard work that went into that. We really do appreciate it. And we're looking forward to the next one. Thank you all for staying for so long. Hope you had fun, learned something. Please go out forth and tell everybody about gemmology and about our courses, because you are our best advertisers. Word of mouth is the most important advertising for the GAA. So we rely on you guys to chat away, have a nice conversation over a cup of tea or something. And even just the intro courses are really interesting to people to get the bug. And you know how passionate you are about it. So it's time to share the fun, share the love. Thanks, guys. Really appreciate it again. Looking forward to the next one.
Oh, give us a bit of time.
Everybody. Stay safe.
All right.
Wash those hands. Look, no things. Washing hands all the time. So take care.
Righto.
Stay safe.
Sorry about the glitch in the early days.
Thanks.
Bye, everybody.
Just keep rolling in.